Hi everyone. The topic of our project is the importance of negative sampling in weak label learning. The problem to be solved here is to select negative sampling strategies to compress the total number of data used for training, but can still retain the classification accuracy. First, I would like to introduce some basic concept. Weak labels here stand for the labels that define the presence of an instance but do not provide the exact location of them within the bag. For example, as we can see here in this image, we have the label cat, but we do not know where it is. While strong labels give the actual location of the cat mostly in the form of bounding boxes, or the exact pixels that belong to the cat. It is apparent that the strong label acquisition is cumbersome and costly, while weak label data is easier to collect. And in real world, more data is in the form of weak label, and that is the motivation of our project. Specifically for audio, which is 1D signal, the label for the data is just the presence of the particular type of sound and do not give the exact occurrence time. The second core concept is the positive and negative bags. Here, each bag contains a bunch of instances. For the positive bags, this contains at least one positive, and also there can be negatives within this bag. In contrast, the negative bags only contain the negative instances. Intuitively, the positive and negative bags are over imbalanced like this. Thus, to reduce the cost and the labor to train on this data, we can simply discard them and use some more informative ones to train. The work done here is called negative sampling. Active learning algorithms sample unlabeled data from a large pool. It will only select the data samples closest to the boundary and disregard the irrelevant data. We will refer to active learning for the ideas of finding the most informative negative data samples. Here comes our strategy. Batch aims to capture uncertainty about an example through the norm of the gradient embedding. It also tries to select the samples with good diversity using the k-means plus seeding algorithm. For SVM margin strategy, we first train with hinge loss. Then for the bag selection, we focus on negative bags that lies in the wrong side and those near the boundaries. Another strategy to mention here is k-error divergence. Intuitively, the negative bags that is more informative should have some similar distribution as the positive. We use this as our guidance for the sampling. Apart from them, there are some other useful strategies as well. Random is our baseline here. For Cypher10, instead of viewing a single image as a bag, we aim at a more general situation and form bags as a collection of images. We start from the bags with fixed size 5, which denotes the proportion of positive data in the positive bags. To alleviate the influence caused by the single images being learned unevenly multiple times, each image only occurs in one bag. We can be seen from this figure. We use CNN-based model for Cypher training and prediction. For audio classification, we use AudioSet. It draws the data from millions of YouTube videos and labels them with about 500 classes. In order to save time, we decided to start with AudioSet 40, a subset extracted from original AudioSet that only contains audio recordings with top 40 classes with the highest frequency. Top 5 classes are shown in this table. Our base model is Walnut, a CNN-based weak classifier, which could take inputs with arbitrary lengths. Here we modify the Walnut to get a binary classification prediction according to our task. However, overfitting is really a huge problem here. To handle this, we use scheduler and add its weight decay to get a slight improvement. We have tried the mentioned sampling strategies on 2 datasets. It turns out that the k-error divergence of final outputs, the SVM margin and the badge, will give a consistent, better performance than random and quite similar to that of the full set. Thank you for the watching.